Hi guys, welcome back. I hope you had a very restful and relaxing spring break, and I hope that your Easter was as good as it could be in these circumstances. So, we are starting our last chapter today, and it is all about matrices. This should hopefully be the easiest chapter we've done. But we're just working with matrices. The next 2 days are on the different operations with matrices, adding, subtracting, and multiplying. And then we'll get into a little bit more specifics with matrices. So first off, what the heck is a matrix? A matrix is a rectangular array of numbers. So it's just a way of writing a group of numbers in rectangular form. They are used a lot in computer programming and things of that nature. Things with encryption use matrices. So the first thing we're going to talk about is the dimensions of a matrix. When you find the dimensions of a matrix, it's always the number of row times the number of columns. So it's always row times column. It's not in alphabetical order, so you need to be careful about that. The other thing you need to be careful about is knowing the difference between what a row is and what a column is. So to get that in your head, when I think of columns, I think of like in Greek architecture, a column goes up and down. So columns go this way, that's a column. And rows go this way. So if I counted the number of rows in number 1, it has 1, 2, 3 rows. So it's going to be 3 by, and then we count the number of columns. There are 2 columns. So this is what's considered a 3 by 2 matrix. That's how we say the dimensions of it, because it has 3 rows times 2 columns. So then if you look at number 2 only has 1 row. So that's 1. And then columns, we count each of these individual numbers as a column. This would have 4 columns. So this is considered a 1 by 4 matrix. So the next part is just how you reference a specific number in the matrix. You can do that by using the letter for the matrix in a lowercase form and then putting 2 numbers after it. The numbers give you the row first and then the column second. It's in the same order as the dimensions. So for number 3, we'd be looking at matrix A, and we'd be looking in row 3, which is down here, and column 2, which is up here, and we'd be giving that element, which is -1. You're just giving that one specific value that falls in that spot. So looking at number 4, we're looking at row 1, which there's only one of, and then we're looking at column 2, and we're giving that element, which would be -2. Okay? All right, now we're going to work with adding and subtracting. When you're adding or subtracting, the elements must correspond with each other. So that means that they have to have the same dimensions. So that's really important for adding and subtracting. They have to be the same size or you can't actually add and subtract. If it happens to not be possible, you have to write undefined, and then you just don't even do the problem. So looking at number 5, if I want to add them, we're just adding the things that are in the same spot together. So it's -3 plus 5 gives me that the first element in the answer is 2. Then I take the next ones, and it would be 4 and 3. 4 plus 3 is 7. Then I take the next ones, -2 and -4 is -6. And then for the last ones, 8 and -2 is +6. And that would be your answer matrix. So it's really simple. You just need to make sure you're matching up the stuff that's in the same spot. For number 6, we're subtracting. For subtracting, I always recommend that you distribute the subtraction. It's going to distribute to every number. And I'm going to distribute the minus sign and change it to plus. I always rewrite it that way so I don't mess up. If you think you're going to be careful enough, you can try and subtract it, but chances are you'll make a mistake with one of the numbers. So I'm going to change it to plus, and I'm going to change all of these to the opposite sign. So it's going to be -1, +3, -5, -4, -7, +2. And then I just have to add them together to get my answer. So that's going to be 3, 4, -5, -7, -5, and 7. and that would be my answer. Okay? All right, looking at number 7, right away you should see that something's weird. We could start matching stuff up. That matches with that, this guy matches with this guy, but then this guy doesn't have a match because these are not the same size. This is a 2 by 2. This is 2 rows, 3 columns. This is a 2 by 3. So since they're not the same size, they don't have the same dimensions, we can't actually add these together. We call this undefined. So they're not the same dimensions. So we're going to write down undefined. We're actually not able to do this operation. All right, number 8 is another subtraction one. Again, just be careful with this. You've got to make sure you distribute that negative sign. So that's what I'm going to do first. I'm going to change it to plus. And then it's going to be positive 6, negative 7, negative 2. And then I'll combine them. So that's going to be 2. And just make sure you're leaving space here. Negative 4, 3. That should be your final answer. All right, something else that's relatively easy is multiplying by a scalar. If you see just a number outside the matrix, that number is going to get distributed into everything to multiply to get your answer. So negative 2 is going to get multiplied by negative 1, we get positive 2. Negative 2 times 5 is negative 10. Negative 2 times 3 is negative 6. Negative 2 times negative 4 is 8. So that would be your answer. So then we can start to put operations together. So number 4, they want us to multiply the first one only by 4. So those are all going to get multiplied by 4. And then afterwards we'll add it. You do need to make sure you follow your order of operations, that you're multiplying before you add. So then we're going to get negative 12, 8, and 20 for the first matrix. And then we have to add that with the second matrix to get our answer. So that's going to be negative 7, negative 2, 23. So that would be our answer for number 10. All right, the last thing we're looking at today is solving a matrix equation, and these will get more complicated a little bit later in the chapter. But your goal is really just to get the x by itself by undoing whatever operations are happening. So you can think of this as just one really large equation that you're trying to get x by itself. So if you look at number 1, to get x by itself, we've got to get rid of the 2. But we're going to have a rule later this chapter that says you never ever divide matrices. So we're not going to do division to get rid of the 2. We're going to think about what we could multiply by to get rid of the 2. To get rid of the 2, I would multiply by 1/2. It's really the same thing as dividing by 2, so if you want to divide by 2, you can. But when we get to bigger problems, there's going to be no division with matrices. So we need to make sure that we're thinking in that form. So if I multiply by 1/2, I'm going to get negative 4, negative 3, 0, 1, 2, and negative 2. And that is going to be my answer to the problem. What that matrix really gives me is if I were to take it and plug it back here, that's the matrix that would go in that spot that if I multiplied it by 2, I would get that matrix that's on the right side originally. So we're just trying to figure out what matrix would have to go there. So then looking at number 2, there's just more operations here. So you need to think about what you need to undo first to get x by itself. You're moving the thing that's farther away. So we're not going to move the negative 3 because that's right next to the x. We're actually going to move this matrix to the other side. So to move this matrix to the other side, you have to think about what operation you have to do to undo it. To undo that matrix, we're going to have to subtract. So it's going to end up getting subtracted on this side. And then since we're subtracting, I'm going to change these to plus the opposite signs so that I subtract properly. On the left, we have negative 3x. I put these up there so it looks like a capital X. You don't have to put the lines there. That's just a math habit of mine. And then we're going to get 3, 0, negative 21, and then negative 15. And then we have to think about what we're going to do to get rid of the negative 3. We can multiply by negative 1/3 by the reciprocal. And I'm going to do that to every element on that side. So that's going to turn into negative 1, 0, 7, 5. And that is my answer to what the x matrix has to be. If I put that back into the original problem, we would end up with 10, 0, -19, -18 at the end. Okay? There are a couple problems for you to try on ClassKick. There is more than one page, so please make sure you go on to the next page after you finish the first page. And then there are just a short assignment for you to practice some of this. Hopefully it's really easy and most of you can get it done within the constraints of our class time. And I will see you guys tomorrow on Zoom.